Hello, and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, graph systems built on the TinkerPop framework, and even applications that are built on those foundations. Today we have a lot more people than we normally have. Today we have a group of graph visualization experts who are here to talk about their experiences building on top of technologies like TinkerPop for the last mile of graph-centric applications. So we have a number of topics to try to cover today, but first we'll just start with some basic introductions from everybody. I'll let everybody kind of introduce themselves. We'll kind of go, I guess, left to right from the screen here, starting with Arthur.
Hey everyone, so my name is Arthur Bouchard. I'm the creator of a tool called G.V. It's a graph database client. Some of you that use Apache TinkerPop might be familiar with it. How I come into graph visualization is that I've worked with a variety of graph visualization frameworks in the development of G.V, and so developing the user experience in the application. I'm hopefully here bringing some useful insights as to the challenges that I've had to work through whilst making the software.
Okay, thank you.
Hey everyone, this is Alexander, version Alex. I'm Janus Graph Technical Steering Committee and Principal Engineer at Mapped. And basically how I got involved into graph visualization tools. At Mapped we had a fork of Gremlin visualizer, which we forked and kind of improved it a bit, and then we contributed it back as a Janus Graph visualizer tool. So it's open source tool. Yeah, that's it.
Hi, I'm Alexis. I work at Westware, a small web agency in France, and I'm the main developer of Sigma.js, graph visualization library for web applications. I started developing web libraries to render networks to help the Jeffy community get ways to share the network maps in web pages. It started in Flash like 15 years ago. Hopefully now it's all JavaScript, and yeah, that's it.
All right, that means it's me. So my name is Chris McGinnis. I'm a principal consultant at Improving, and I'm the lead contributor on Graph Explorer, which is an open source tool that allows visualizing data across both property graph databases and RDF databases.
Great, I think I'm last. I'm Christian Miles. I've been interested in graph visualization and related technologies for, I guess, over a decade now. Mostly with industry experience working with companies and government agencies in the UK, Canada, and the US. A bit of a personal interest. I used to have a newsletter called Source Target, some of you may have heard of, that was digging into some of the interesting thoughts around network visualization and graph visualization. And then in my day job, I work for Cambridge Intelligence. So our most popular framework, or most obvious one in the market is Keylines, which has been around for a number of years, which is, again, web-based graph visualization.
Okay, well, thank you so much. And also thank all of you for joining today to do this. I guess we'll start with kind of the first topic that we talked about in adding here. Bring that up here, graph visualizations, dots and lines. How can that representation be more intuitive? Chris, this was something I think you had brought up as something you want to talk about. Would you like to kind of frame that a little bit more?
Yeah, all I have are questions for you. I don't really have a whole lot of answers, but the questions boil down to, what do you do with graph data, right? Like, there's a lot of different ways you could represent that data. You may be, as a user of a tool that visualizes that graph data, you could be asking different questions. And those different questions about your data really need to be solved by different features and different visualization options, for lack of a better term, which makes the solution phase for this extremely broad. And I think that's why you see a bunch of tools that we're all representing here, all taking a slightly different approach. For instance, the Graph Explorer approach is you typically start with a single node and you expand out from there. And I think other tools, jump in when you feel ready, take a different approach. For instance, G.V, I know you start with a query, and that could represent a whole graph, or it could represent a single node. Is that correct?
Yeah, that's right. I guess to kind of jump off of that starting point when it comes to graph visualization, there's a few kind of key aspects to the visualization, I think, to consider, and they're the ones that are going to drive how we make the visualization useful. Because it's one thing to chuck a bunch of, dots and lines on the screen. It's a completely different topic to then make those have a meaning. And I think one thing people sometimes don't realize is meaning comes across in a lot of ways and shapes as well. So I guess maybe to kind of help with the conversation of dots and lines and how we can make them more useful, I'll share my screen. We'll put a little graph visualization for everyone to see that actually uses a lot of the available tools, I think, in terms of graph data visualization to create the meaning of those dots and lines. And then we can kind of jump on, those topics to see how exactly those are useful. So let me just share my screen here. I'll be very quick. There you go. I'll just do 10 seconds what's going on here. So this is a graph visualization. In this case, it's using Sigma.js, but I think really quickly, what we see is, colors, we see images, we see different sizes, we see a general layout, and we see controls and organization of the data. And all of these factors combined help visually disseminate information. And these are some of the key aspects to consider. I guess, would anyone want to try and talk about, for instance, layout? I think, Alexis, you're fairly familiar with the topic of graph layout. Do you want to maybe just explain to everyone why layout graph data and what the options available are and the things to consider?
Yeah, sure. So the main solution we use in the Jeffy community are force-directed layouts. Basically, it works as considering each pair of nodes as pair of magnets that repulse each other, and every connection between two nodes acts as an elastic. And with this simple force model, you just run it for some iterations, and you end up with something quite stable. And the goal is that close nodes have a higher chance to be connected or to have common neighbors. And when two nodes are far from each other, you can, as a reader, suppose that they are not connected. So this creates kind of clusters, visual clusters, and this allows having these signals, like in the map you're showing here. So this map is a network of Wikipedia pages, and this layout allows you to just get some idea of some dense parts of the network. Some words like you see bioinformatics is next to phylogenetics. Those are all Wikipedia pages about data visualization. You will have some parts about computing, some parts about algorithms, some part about what business fields use data visualization, and you can visually see this kind of information. It's hard to do because it doesn't work the same with different networks. Sorry, it doesn't work the same with different networks. When networks are too dense or less dense or bigger, it's hard. You have lots of biases you want to avoid. But when you have, let's say, take the easiest network you can imagine. If you have three nodes connected to each other, I'm trying to show my hand just about the question. It's easy. There is one good solution. You have every node is at the same distance of each other of every other nodes, and the information is good. If you have 4 nodes connected to each other, you have 2 stable points basically. This one, where each node is closer to the next to the ones on basically diagonals are longer than sides of the square. So this is biased because you think that this node is closer to this one than this one. And the other solution that is stable is 3 nodes and 1 at the middle. Those are the 2 minimal places of energy when you run the physics model. And if you have this result, it's biased as well because the center node seems more important than the other ones. And this single, if you see that it's already hard to get a correct layout representation of a graph of 4 nodes, when you have 1,000 or thousands of nodes, it's even harder.
That's really interesting. So like we do have like thousands of nodes and edges displaying on this one, for instance. And I guess one of the things that kind of immediately strikes is that it's quite decluttered. You know, when you think about the fact that there's 7,000 elements visually represented here, it doesn't seem obvious looking at a glance. But I guess the force layout in this case, does a good job of spacing out the graph. There's other graph layout algorithms available out there. Christian, I'm not sure if you've got any wisdom to add there on the topic of graph layout according maybe to specific graph shapes or archetypes like trees and such.
Yeah, it's a good point. I guess just to emphasize something you said, Alexis, around, I guess we have a consensus that there's no one perfect layout for every graph, right? Like, I don't think anyone is like, this is picture perfect and it is exactly what I need for all uses of this data, right? So, and that's something we see, that's something I see all the time. Like, the web technologies that are out there, including ours, mean that you're able to pivot between different views so that you can get the one that makes the most sense to you. And that extends beyond layouts. It's also for like, colors and labels even. And so, yeah, we get a lot of mileage out of our sequential layout, which is a fantastic way of showing those trees, or the directed acyclic graphs where there are some loops back in the graphs. Our products do a great job at laying those out. And that often is toggled between that one and our more organic sort of view that looks a bit more like this. But I'm kind of curious, Alexis, maybe the layout here, how would you ideally improve this layout for this network to be used more effectively? What do you think are the deficiencies in the view that's shown right now?
That's a good question. I personally like it because I know how to read it. I know that being at the center of this map might not be a strong signal, but I know that groups of nodes basically is something strong enough. We could get something more schematic by just doing circle packing, for instance. That could be something different. It would look simpler, and maybe some people might like it better.
And just to clarify,
sorry, go ahead.
Where you group multiple nodes together as a single node, is that correct?
No. I was just suggesting, like, instead of having this kind of organic representation where the position, it's quite funny to see the algorithm run. Actually, I could do a setup after this question. You could get something more like put nodes on a grid. You know that all the blue nodes will be close together on the map, so you just put them in a regular grid somewhere, and all the green nodes somewhere else, etc.
Yeah.
I guess maybe to contextualize, sorry, really quick, this is what Circle Pack kind of looks like. Effectively, is a bunch of clusters, because you mentioned Circle Pack, but I think maybe just to help the audience here visualize what that means, it's essentially like a bubble chart. If you've ever seen a bubble chart, that's what Circle Pack does. Except it does it with a group of nodes that are organized into clusters. They're effectively your bubbles. So, I mean, looking at this one, here's a bubble, that's another bubble. We've got a very big bubble right in the middle. It's very prominent, etc., etc. So like that's a good way of laying out graph data that can be organized into communities, which is essentially attributes that this sort of depicts them as being part of the same group. A community, for instance, could be like a country or a city or some other kind of identifier, but just to contextualize a little bit there on the circle pack side of things and how it can help. This is still a cluttered view to an extent, but shapes are very prominent coming out of it. And you can very, very quickly see that you do have, in fact, defined clusters. You can practically draw, the bubbles around each of those to see how they're organized. I guess one thing maybe that's interesting to talk about as well is, so we've talked about, when we talk about layouts here, we're going to talk about them as this thing that you run, and it's just going to do the job for you, and you're kind of done, and it's going to possibly go well, possibly not. But like layouts can sometimes be a bit more manual as well. I think it's kind of important to remember, as has been said, like different archetypes of graph data and structure lend themselves to different needs. Like a highly clustered, data sets will work quite well with circle pack, for instance. A not too dense, but not too small graph will work quite well with forced layout to decluster it. But I love this example from Cytoscape, which is, you can find on the Cytoscape.js website. We'll probably come back to this, the wine and cheese map, which is basically, on the left side, you have red wines. On the right side, you have white wines. And in the middle, you have cheese. And having described this, you can sort of visually see what's going on. If you're, if you know that on this graph there's red wines, white wines, and cheese, you don't actually need to read the labels to know what each of these things is, right? The colors kind of tell you what each of these things is. Red wine being red, white wine, cheese being yellow, which I suppose it's not always, but we'll work with that. The other really interesting thing here is the layout, because it's kind of custom and not custom at the same time.
Yeah.
So for instance, the left-hand side and the right-hand side are custom. We're just saying, okay, it's like a shelf of wine, quite literally. It's like we'll just stack them on top of each other. They're going to be on either side of the graph. And then between those wines is the cheeses that are kind of pooled between both of these wines based on their majority pairings, right? So like on the left-hand side are going to be wines that are pairing more with red. On the right-hand side are going to be wines that pair more with white, cheese that pair more with white wines. And so this is really interesting because this layout, which is quite bespoke, does a really good job of telling you a whole story just from one picture. I just kind of want to see what everyone's thinking about this one, if they've seen it before.
I've seen it, and yeah, I love the direction of it. I'm going to be a bit controversial though. I think that we love throwing graph viz at a lot of data, and in reality, I think sometimes it's a little bit. What I'm trying to say really is that there are some facets of this data, there's some angles of looking at this data where maybe a Sankey diagram makes more sense, or even coloring those individual nodes based on where they're connected to those wines might be more interesting. I love hybrid graphs and I love these like innovative approaches, but I immediately see all these red lines crossing over like most of the network, and I can't really get much info from that just by zooming in and panning around, right? I think we should always, the bit in the middle is the core key connectivity, which is very hard to display any other way, and that's where the dots and lines come in. But the bits on the side, to me, they're more like categorical or circumstantial information that might be better served with a different view.
Yeah, absolutely.
Happy to be argued with, but that's my take.
I personally agree. I think graph visualization is something that we instinctively want to do when we deal with graph data because it looks cool when it's done right. But the goal of graph visualization is not to look cool, even though it's a nice side effect. The goal of graph visualization is to convey information and to deliver value for those that are going to be interacting with it. And sometimes you'll see that even just a simple table will convey the information better than a graph visualization. So it's really important to think about your sort of domain in terms of the visualization problem that you're trying to solve. And then with that domain fully understood, to then apply the right techniques like coloring, sizing, layout, etc. But before you even get to that, absolutely right. You need graph visualization because if you don't need graph visualization, there's possibly a simpler solution available, and there's a wealth of other data visualization techniques available, which I guess Christian at Keylines or Cambridge Intelligence will be quite familiar with as well, because you guys do quite a few other of those libraries, but well worth pointing out. Chris, I don't know what's your thoughts on that.
Yeah, so I think y'all are hitting on maybe the key aspect of graph visualization. The key here is when you're visualizing it with nodes and edges, you're throwing away so much information. You're throwing away the names and attributes of all this data. All you're visualizing is, does it exist and what is it related to? And so if your questions are not answered by those 2 points, graph visualization might not be the answer for you. But if you're looking for that relationship and patterns in the relationship, there's really no other alternative, right? Graph visualization is the best tool for visualizing those connections and finding patterns in those connections.
Yeah.
Can I ask what the mechanism was for producing this wine and cheese thing? Like,
So that's made by the contributors or maintainers of Sitescape.js. This is actually something you can access directly from the Sitescape.js website, which I'll quickly show right here, where they have a whole bunch of examples. I highly recommend those in the audience to take a look, because these are graph visualizations. Some of these graph visualizations, not all of them, in fact, clearly solve specific visualization problems. This one, for instance, is kind of interesting because transit network is effectively a graph, and therefore representing that as a form of graph visualization, even though it doesn't look like it entirely, is an interesting use case. Those kind of more advanced diagrams here as well are quite interesting because they show context being added to the visualization. When I talked about these bubbles in the community layout, well, those are your bubbles effectively, but labeled accordingly as well. I believe this one is maybe drug related or chemical related. Apologies, I'm not very scientific with this stuff. But just to kind of highlight how different, like there are definitely lots of scope for useful visualization, but you really gotta think about the domain of that visualization, what it's trying to achieve.
but someone I assume someone programmatically organized that?
Absolutely.
Okay, so
should we
somebody,
maybe jump onto the topic of kind of open source libraries to kind of
yeah,
seamlessly
absolutely.
transition into how exactly those are used?
Yeah, absolutely.
Cool. Yeah, I mean, so really at the core, we're looking at JavaScript libraries here. That's not always JavaScript libraries, but I think quite often just the way of things, everything is kind of running on the web, and visualization libraries will primarily be written in JavaScript and consumed in JavaScript. Chris, do you wanna? You guys use Sitescape.js in Graph Explorer, right?
That's correct.
Do you want to maybe talk through Sitescape.js a little bit?
I don't get to deal with Sitescape directly all that often. I'm working mostly with a React wrapper, a custom React wrapper around Sitescape, which adds its own set of complexities and render and performance issues. It is really not a simple topic to use React with a graph visualization tool. But so far, Sitescape has been really good at allowing us to style nodes and edges in a vast assortment of ways. I don't think we're using Sitescape to its full potential in Graph Explorer, so there's definitely room for improvement there. But it is a very powerful tool, and it's at least for when it was chosen, it was a very good choice to make.
Do you find yourself battling with the React integration there? Do you ever have to go to the internals, or is the wrapper good for you?
I do end up battling it, but it's mostly for performance reasons, not necessarily interactivity reasons.
Sure.
Because React is built on re-rendering constantly.
Yeah.
Visualization wants stability. It makes it very difficult.
I think that there are so many complexities when building applications with graphs. Our transition to having a library that was focused on React was a fantastic way of helping people get to a usable, performant graph a lot sooner. So like our original libraries were just pure JavaScript, and yeah, there was mention of Flash earlier. We had a Flash version back in the day, but more recently, I think many of our customers are using the React version of our library, and the fact that you can basically be data driven and just pass it the items you want to visualize and not worry so much about the underlying rendering is fantastic.
And we're talking about Sigma.js here, right?
Well, I think that
sorry.
generally applies across board. But I think that there's kind of two topics here. There's like the graph visualization libraries, and then there's a wrapper around this. I was gonna say, Alexis, you've probably got good things to say about this because Sigma.js has, like, I'm showing the architecture here, but it kind of highlights what makes a graph visualization library. Do you want to just tell us more about the kind of separation between the handling of the graph data and the handling of the visualization itself, and how that kind of plays together in the graph visualization library?
Yeah, sure. So basically, in the JFA community, we have lots of people who need to generate network maps. And some of these people just need to generate a PNG image on Node.js scripts, for instance. So very early, we had all this code packed inside Sigma.js, and on the other side, people trying to put Sigma.js in Node.js scripts, but that Node.js doesn't support Canvas APIs. So it's time we had issues. So it became very important for us to separate everything data related, algorithms, traversal, etc. So basically the graph model. And on the other side, the rendering. That's why we split graphology, which is developed by somebody else, actually, a very close friend, but he's handling all the data part, and I deal with rendering only. So this split is here for this. Also, for React, especially, we have a good wrapper because it's developed by a colleague of mine. So it's quite easy to work with Sigma.js in React applications, but we cheat a bit. We don't put nodes and edges as React nodes because this would become just absolutely awful. The API looks more like React map.gl. I don't know if you've worked with it. You put a root node and it just spread the context, basically. And within this thing, you can mount components that will handle different topics. Like one will handle camera management, another component will handle all the events, another one the graph data lifecycle, these kind of things. So you don't have too much rendering issues because Sigma re-renders the WebGL part only when the input data has been actually changed. And graphology is very nice because you can script things you would do in your web applications backend side, and quite like this part.
I think of it sometimes as like a standard library for graph stuff, analytics or the graph theoretical stuff. Is that a fair assessment?
Yes, and another cool thing, and we really like it, is that you could work with NVG sets or even keylines, and you might want the graphology implementation. You can take graphology, which is open source, and you won't have Sigma.js packed with it. You really can put graphology, make it work with some other rendering libraries.
Yeah.
And I love that approach for graphology as all it is focused on is managing the data of the graph and providing events to the rendering engine to change its state. I think that's a great approach. I'm actually looking into it, like it's just experimenting with it as like, how can I make this work with Cytoscape? Like it will maybe solve some of my React issues.
We're touching on there upon the data flow as well, right? Like I see graphology and graph engines. We have a graph engine as well, so it's kind of decoupled from the rendering. I see those as sort of middle ground between a TinkerPop backend or even a graph analytics backend and the front end, right? It's all, I don't know, is it isomorphic? You could run it wherever you want, really, to do the workloads that may be a bit more accessible for the front end. So I'm wondering if that's a good segue for Alex around talking around the database angle of this sort of thing. Like how much do you see this related to providing the visuals versus the stuff that actually probably should be run on the database?
So I guess I was just going to briefly mention, so graphology, just to kind of situate in a really easy way for everyone, think about Network X. It's a graph analytics library in Python. You represent graphs, then you can run algorithms. Graphology does basically that for, the web side of things. So that's the sort of easiest way to understand it. So sorry, what was your question, Christian, on how we interact with databases from there?
Yeah, just wondering what people's view is on the line between sort of like pre-processing done in the browser, pre-processing done maybe server side as some sort of middleware, or even just pre-computed stuff on the database side. Like, what's the benefit of? Where do you see those lines being drawn, basically?
So, like for instance, how we translate the data from the database into something that is then going to be rendered. I guess for TinkerPop, really, in graphology, for instance, we're talking about nodes with properties and edges with properties. If you're lucky, which more often than not you will be with those JavaScript graph visualization libraries, they all kind of operate on the property graph model. And so that means they're inherently capable of like supporting these. So if you kind of return the elements of your database enriched with those properties, they translate very easily to those JavaScript libraries. With TinkerPop, especially since 3.7.0, when they've introduced the ability to include properties on elements when they're being returned by the TinkerPop API, that makes that translation just immensely easier, because really all you need to do is if you run g.e.limit 100 on TinkerPop, what you're actually going to get is a fully fledged property graph that you can plug more or less directly into one of those visualization libraries and get them to just render it, because the structure of the TinkerPop property graph model and the structure of those graph visualization libraries are very similar. All you're going to be see is like some slight translation layers, like there might need to be some properties might need to be renamed, but it's just a simple exercise of shifting the documents in some way. That's at least been my experience with GLD. Chris, I guess you probably have. Actually, Chris, I think knows a lot more, because he's not just doing this for TinkerPop, he's doing this for Cypher, and more importantly, I think for RDF, which is not a property graph model. So I think that'd be really interesting to hear your thoughts on that.
You're absolutely right. Gremlin makes this pretty straightforward. OpenCypher is not too terrible. It's not different compared to Gremlin in its result set. It gives you a lot of the information you need. But both Gremlin and OpenCypher require additional queries, at least in Graph Explorer's case, to fully render the results. Makes it complicated, not impossible, just complicated. Maybe a little taxing on the database as well, because we're firing off a lot of extra queries. Sparkle and RDF is an entirely different beast, as you alluded to. The way it represents data is completely different than property graphs. Graph Explorer has done a fairly good job of kind of shoving RDF data into the property graph model. But it does that a lot with a lot of custom queries and additional queries to combine the data in a way that makes sense in a property graph thought process. And I would say there's definitely some room for improvement there, but I'm fairly impressed with what the developers did before my time on Graph Explorer to make RDF work in that same visualization tool. It's not easy.
From your perspective, Alexander, I think because you've kind of used JavaScript visualization, well, rather, you've used the ancestor of JavaScript visualizer and then turned it into what it is now. What was the sort of setup like on this one? And I know it's been made before 3.7.0 of TinkerPop, so I'm assuming there are similar challenges there. Do you want to just cover that a bit?
Yeah. Again, I wasn't involved too much in the front-end development of the visualization, more on the automation maybe. But yeah, we basically had to, at Mapped, that we basically had to show our customers graphs because we manage their own graphs. Yeah, and also we needed a tool to internally, look at the graphs of different customers, understand what's going on, they keep anomalies, why, and so on. And that's why we decided that we need kind of a browser visualizer. And we found this Gremlin visualizer, which was good, but had some small flaws. And we just improved it so that we can switch between different graphs, between different graph traversal sources in the same browser and just see the data. However, I mean, it works good, and it is now contributed as Janus Graph Visualizer. And I can show it if necessary. I guess actually, let me share my screen. I just
let me unshare real quick. There we go.
Yeah,
and I think Janus Graph Visualizer, sorry, kind of operates similar to AWS Graph Explorer and G.V, I believe, which is sometimes you just have to go get those properties from our vertices and edges. That's kind of the key thing. Some databases like Neo4j or OpenCipher based ones will just include that information outright, which means you run your query and then boom, you've got your data exactly as it needs to be. TinkerPop, it's a 50-50. Depending on which version you're using, either you're going to have this information because by default, it's configured to materialize properties, I believe as it's called, which is to include properties elements, or it's not going to include information, in which case you'll need to go and find that on top of your vertices and edges. And the way to do that is really to just take your vertex / edge IDs and to just submit a separate query that's just going to get the properties. Typically, we'll be using property map or value map or element map. All these will kind of give you all that information and just allow you to enrich your nodes and edges with the actual properties that give it meaning ultimately, because if you don't have the properties of your elements, you've got nothing to actually drive the visualization from. You're losing the ability to label your data, which is super important. You're potentially losing the ability to lay out your data as well if you're using stuff like community-based layouts, which rely on those property values. Sizing as well can be affected, coloring. A lot of the graph visualization aspects can be driven from the data that you're giving. So like a typical example is like, you could size transactions by their amount on the graph. And what will immediately become apparent is that the biggest one is the most expensive ones. Super important to include those properties. So you need to kind of see how when you're working with the backend technology, what the information it gives you actually is and what you can do with it. And if you're lacking it, the step is to go and fetch it. And to be fair, I would say, and that's sort of my personal development experience with TinkerPop, it's not that expensive to go fetch a bunch of properties from a few vertices using their ID. Not unless you've got thousands of them, and if you've got thousands and thousands of elements to represent, fetching their properties might not necessarily be your bigger problem. Like, the bigger problem is going to be how you're going to make that a useful visualization. Is it worth maybe moving on to one of the other topics, just being mindful of time? I believe we've got. Do I do 3D graph visualization? Do I talk about this one a little bit? I think it's an entertaining topic.
Which topic?
3D graph visualization.
Oh,
Let's
3D.
go. So I'll present my screen. Okay. I kind of want to hear everyone's thoughts on this because I think it's one of those things we just gotta talk about because it keeps kind of making little waves. So I guess maybe just quickly for the uninitiated, 3D graph visualization is graph visualization on a three-dimensional plane, right? So it's like going from Super Nintendo to Nintendo 64, so to speak. And I think looking at that, there were some challenges back then. There possibly are challenges here too. But I want to hear what people's takes on 3D graph visualization is. So Alexis, I'm wondering what you're thinking about this and how that comes into play with Sigma.js, which I guess uses WebGL and could technically do it.
Oh yeah, we could. And actually, once I've had a very good use case for a 3D visualization. It was 15 years ago. We were working on Basically, I was working in the Complex System Institute in Paris, and I forked Gephi to render graphs in 3D, which was kind of possible in the code at the time. And we had huge networks of keywords connected by co-occurrences in a huge PubMed co-citation network. With one key point is that keywords were appearing once per year. And we had like a graph per year. And this graph is kind of what you can imagine co-citation network is. And co-citation, co-occurrences network, sorry. And vertical connections between the same keyword on 2 consecutive years. And we run a 4-directed layout where each node is constrained on a plan corresponding to its year. And we saw kind of the science as a forest. And this was great because we had like emerging, sometimes one big trunk was splitting into 2 smaller trunks, because a field was split into 2 different fields. And sometimes you had, on the opposite, trunks joining each other to become a bigger tree. This was really great. It was awful to manipulate, really awful, because basically what you see is still in 2D. So you have to manipulate to get sense of the data. If you don't manipulate, you have a 2D image, which is even more biased than what we discussed earlier. Apart from that point, I've never seen a very decent use case, actually.
That manipulation bit is key, and unless you have that, yes, I think there are some significant deficiencies. Like most of our screens are 2D, right? So unless you start interacting with it, which has its own accessibility issues as well, that's challenging. I think that we're not going to see a push or a breakthrough in this until like AR, VR goggles are more mainstream, right? I haven't had any experience with that myself, but until we're in these like work environments where we're wearing goggles all the time, I just can't see it being that powerful. But the 2 headline reasons why I'm not a fan of 3D. The first, going back to your point, Arthur, you talked about how sizing can show you something important, like a dollar amount assigned to a node or some sort of impact for that node. You immediately lose that in 3D because the sizing, of course, represents how close you are to a node in this strange world where it's floating in the air in front of you, right? So that is such a key attribute that you want to show off in the front end. And if you can't, then you're kind of hobbling yourself a little bit. And secondly, occlusion. Like if I can't see an important node because it's hidden behind another one, I don't think that's a very good visualization. And I don't want to have to be like shifting it left and right to kind of spot it in the distance. I don't think that is a serious way of interacting with complex data in the current way that we do right now. But that's my take.
What about you, Chris? Are we gonna get 3D visualization in AWS Graph Explorer? Or is that a non-starter for you guys?
Oh man, I hesitate to say there's a good use case for it. Like Christian was saying, it removes a lot of information. So kind of the way I think about it personally is I kind of view table data as like maybe the 1D representation. Graph visualization is the 2D representation. They both show different types of data, right? One showing a lot of textual and value information. The other is showing relationship information. Then you get to 3D. What extra information are you finding in that 3D environment? You're not finding extra relationship data that's already there. You're getting a lot of data lost, like Christian was bringing up. So what value is it adding? I haven't seen a good answer for that yet.
So in the example I was discussing earlier, you have another dimension which represents another data dimension, which makes sense. But the main gain is actually, you remember this 4 nodes graph I was discussing earlier. In 3D, it works. In 3D, it works because each node is the same distance from every other node. Mm-hmm. Basically, you have more unfolding power in 3 dimension. You still have bias, but lots of networks maps are the famous hurdles. And when you have those hurdles, one of the biggest issues is that you have lots of nodes that are very close to each other in the middle of the image that are actually not that much connected. In 3D, you kind of have more unfolding power, and those clusters will be more separated. This is the main goal. But in my opinion, if you have this kind of too much connected graphs, for directed layouts won't be a solution. But yeah, this is the main gain, I think.
I agree. I think with 3D visualization, so I'm sort of mostly on the, it looks cool, but it's kind of not very useful for all the reason Christian has explained. But I agree with Alexis that I think where 3D provides value is when there's a requirement for different planes, effectively, of data. And I actually really quite like this example. This is from Kinevis. They have a graph visualization solution as well. And that actually represents the planes problem quite well, where at the bottom you have a map. And atop the map, you have everything that cannot be placed on the map. And I think this is a situation where 3D kind of works, but it doesn't work in the traditional sense where we're thinking, oh, it's complete 3D, you can rotate it, etc. It kind of just works more as isometric 3 dimensions almost. And I think this is potentially where there's a valuable compromise with 3D graph visualization, is when data can be represented sort of in 3D, but more as of a trick of the eye than an actual fully 3D rendered, fully free navigatable environment, because as Christian explained, that 3D navigatable environment is going to be tricky.
That sometimes comes up as sort of like a 2.5D, where there's another dimension that you're kind of taking advantage of. I'm going to be annoying again, though. In this example, those nodes that are floating in the air, they don't look like they're giving you any information on that axis. It looks like they're more attributes or categories of those nodes below.
Yeah.
So I think you're onto the right thing. This is a good start for like the cases where there are instances where you want to have it at different levels. But I think it's not a solved problem, right? I think it's hard to work out the right approach to it.
Yeah. Technically speaking, I think it's extremely challenging as well to work with this kind of representation, especially if you think about a situation we've got like more than 2 planes, because we really only got 2 planes here. I think as Christian mentioned, like there's absolutely no need for these to be so vertical, right? But it could be a situation where you imagine if there were 5 different types of objects that linked to stuff on the map, but that weren't the same type of objects. Then having separate planes, almost like a sandwich of data, would make sense, in the sense that we're grouping the same categories of objects on a specific plane, and those categories of objects might then link to each other as a sort of going atop the tower type of situation.
Like a 4D chess, 3D chess.
Yeah, and that would potentially provide valuable information, but I mean, from an implementation perspective, extremely challenging, because your layout is becoming not just a matter of like the individual 2D planes, but how they then relate to each other as well. And there's a question of sizing as well. And if you're using isometric 3D, stuff that's at the back of the plane is going to look a little bit smaller. Do you put less important stuff at the back? Do you put the forefront? Because they're smaller and therefore you're going to be able to see them. There's a whole bunch of stuff there to consider. But I thought it'd be an interesting example, kind of like what Alexis said, of like, this is visually what it could look like, and this is where it could be applicable.
Hey, we had a question come in on Twitch. I thought I might want to just address that real quick. While bigger is better, do you guys see an increase in interest in using graph modeling? Space, rooms, graphs and buildings, power distribution. These networks are often between the hello world and the statistics type viz you see on big data, and they're also typically captured in relational databases. Any comments on that?
I mean, at Mapped, we actually use graphs specifically to represent people, places, and things. And by places, I mean this rooms, or different spaces, floors, buildings, zones, and etc. So mostly for industrial, commercial buildings. And there are a lot of connections, and we do use it a lot. We do use a lot of graphs, let's say, even for a single customer who has a single single place, like a building or room. It's represented by an identity graph, where the same node can be identified in different systems. And we need to take all of this data and kind of compress it and normalize. So we do use graphs a lot, data modeling for this. However, if we talk about visualization part, specifically visualization part, some things which all current solutions lack, I think, and it would be really great if we had some graph visualizer capable. I don't have a good solution in my mind how to solve it, but regarding the data ingestion, how do we visualize data ingestion in graph world? Currently, we visualize graphs. Yeah, all the visualizers, they visualize a final state of the graph, right? The nodes, vertices, and edges. In our case, we have one graph. Let's say we call it current, and another graph which we want to absorb in the current graph. And this operation absorbing as one graph into another graph produces a third graph. Yeah, so we have graph A, graph B, and graph C. The graph A is the ingestion graph, graph B is our current graph, and graph C is the result of absorbing those two graphs together. How do we visualize this to a customer or to anybody? I think it might be really useful in different industries. If we have some kind of group of nodes and another group of nodes, and we absorb data, we modify our current graph.
Sort of like a temporal graph, basically, like a graph that is evolving over time. I mean, Christian is that kind of makes me think of chronograph immediately here. Don't know if you want to touch on that.
Yeah. I guess we're running up on time, but one thing I would just mention is that when we talk about like extra dimensions and when we think about like volumes of data, our view at Cambridge Intelligence is that dimension is typically something that's a bit more tangible, like time. Pretty much all graphs have some sort of velocity, have some sort of time dimension, and we have lots of really great ways of visualizing and helping people interact with those graphs. And then the other dimension, kind of in alignment with some of the stuff around dimensions, is geospatial. We get a lot of interest in people looking to look at things in the real world where things actually exist and interact. And again, all these problems are unsolved. There are many different ways to approach the problem, and our goal is to have toolkits that can help people in that sort of corporate enterprise distribution space. But we're doing some really interesting work on that in terms of R&D, in terms of our products to help people visualize the data in whatever form they need it to be shown as.
I was going to say on the original question, one really important thing to note is that you can use a graph database to solve a problem.
Yeah.
You can use graph visualization to visualize whatever information you're trying to convey, but you don't actually need necessarily a graph database to have a graph visualization. Ultimately, you can build graph visualization on top of relational data, because guess what? Relational data is still connected. It's kind of there in the name. And therefore, I think it's important to separate your needs for representation in terms of graph for your database, which is where you're going to compute potentially expensive queries where the graph kind of nature will make it more efficient. For instance, if you're gonna have to do like lots of joins, like very deep joins, etc., you're probably gonna want a graph database. Whereas if you're on a more simple join structure with data, relational database, which have been around for decades, is gonna do the job just fine. But that doesn't stop you from using graph visualization to solve on an investigative problem, like a supply chain visualization, for instance. There's a good argument, right? It's a common use case for graph databases. It's a very good argument to say use a graph database for supply chain because it's going to be much easier to calculate your paths, etc. You could technically do it on a relational database. Supply chain has been getting solved for a long time, and graph databases weren't always there for it. So it has been done in relational database, but supply chain visualization, reporting on a path of stuff going through the supply chain, that works really well as a graph visualization. I think it's just key to understand that there's a very big difference between solving problems for graph visualizations with graph visualizations, and solving problem with graph databases for highly interconnected, deeply joined data. And I think those are two key things to separate. They're not mutually exclusive. You can use relational to graph visualization, vice versa. In fact, you can view graph data as tables. Ultimately, vertices organized by labels, they're just tables, really. The tables, and that's the properties are the columns. So these two worlds really intersect quite a lot. And I think that's interesting to remember.
Okay. Maybe as we kind of close in on the last moments here, I don't know if there was anything we wanted to actually close with. We did get a question on Twitch. It was kind of already in the in kind of our list of things to kind of talk about. Those of you who are working with a TinkerPop based system, I think a TinkerPop member, and again, including myself as a longtime contributor, I'm curious. I'm always curious when I get to talk to providers, just like what could TinkerPop do to make something easier? Are there some rough spots? What could do that?
I mean, specifically for graph visualization, since materialized properties has been introduced, it's been a massive help. I have a specific problem, which is that I have to be compatible with tons of Apache TinkerPop databases. I have to compose with some doing it, some not doing it. So I can't fully leverage it. But I think for people that are just going to stick to a specific graph database, I don't have this cross compatibility need I have. It's great. Actually, from a developer's perspective, forgetting about visualization a lot, just being able to get the properties with your elements kind of joins onto what OpenCipher does, for instance, or Cypher in general, which is what everyone kind of expects, but it just also makes it a lot easier. So I'd say we're pretty good on that front.
I'd add to that, it's dramatically better nowadays. I remember 10 years ago, it was, I don't know if 10 years is quite right, but yeah, it's you're on the right track for sure.
Okay. I think one of the things that probably could be helpful is going to be like when, subgraph and tree and Cole Group brought this up in the chat is, potentially those things being more accessible in being able to grab large swaths of a graph at one time. Maybe that will be helpful in some of those cases. So, but yeah, good to know that there's nothing like really standing out as crucial. On the other hand, I wonder what else we're missing that could like make things infinitely easier for folks. But we'll, you're all in Discord. You can always yell. So we'll keep an ear out for you.
Well, one call out I'll make in that topic is it's very difficult for tools like Graph Explorer to understand the data model unless it's told ahead of time. Mm-hmm. So there are queries that you could perform to get the data model, but as the database itself grows, those queries become very expensive. So some amount of work there would be very helpful for tools like Graph Explorer.
Yeah, schema probably be another big one for folks, I think.
Janus Graph's schema API is a bit of a godsend. So when you want to load the schema of a TinkerPop database and you happen to be using Janus Graph with defined schema constraints, it's just lovely. Super easy to fetch, instant. Like Chris said, you don't need explorational queries, I guess I could call them. Where you're essentially just sampling the data, which can be really expensive. I guess I don't know how AWS Graph Explorer does it, but G.V offers different options. One of them being just to not do that and to instead, build a graph data model as the data is being discovered through queries. That's definitely a challenge, and I think it's kind of down, I guess, to specific providers because you need to have a schema first approach or a sort of schema remember type approach, which is what Neo4j does, I guess, with APOC and their schema API, where they kind of just keep track of what's being put in. Don't know if that's achievable within TinkerPop, but if that were ever possible, that would be massive, I would say, for people that develop tools like Chris and I, at the very least. I'm not sure for the average developer this is going to be high value, so we might be the loud minority here. But absolutely, yeah, that's a really good point.
Okay. All right. Well, I think we're at the top of the hour here. Thank all of you for joining today. It was really neat how this all kind of came together too, I think. I mean, people were chatting away on Discord, and we said, oh, why not turn this into something where we can kind of talk more like real time and see each other here on the internet. So thank you all for joining, participating, and thank you everybody for watching. Until the next one, take care.
Thanks so much.
Thank you.
Thank you. Bye.